Right. We are live for day 18 of Value in the Code 2024, the 10th year. And we have about 15 minutes. So let's start with a bit of review and refactor of day 17. Let's see. One of the things I want to do, I have a bunch of test code down here. I'm doing a lot of manipulation to kind of make what I want in order to test it. And there's a lot of noise in this, so I want to make that more of a DSL there. And similarly here, I don't like putting this arrow to none all over the place. Too much to read. There's a bunch of shared code here that just, I want all these to be simple to read. So it's simple to verify that they're correct, at least visually. Yeah, so we'll be making things a bit more concise. Okay, in this case here, one thing you can do, you can use an or between cases. So 3, 4. So if it's 1, 2, no, 0, 1, 2, or 3, and we can assign that a name n, then we just return n. So if n is one of those values, we just return it. And that is good. A, B, and C taken mod 8. All right. I want helpers here for what kind of output we're having. So let's do def no out. So this will give us another CPU state. Sure, no output, fine. And it'll be like this cons onto none. So these are helpers for the next, because I think next is really the only, well, let's just split these up. So literal and opcode are helpers for that are used within here. Advanced kind of transitions this. So this returns another CPU. So that could be public. We'll leave these public as well, because that's useful for debugging. Running combo literal. Okay. And if we had outputs, we're going to output something. So n is some sort of int, and that'll be this to sum of that value. Okay. So all these cases where we have arrow to none, we can do no output. Exactly. 4, 5, 6, 7. So there are 7 of those. And I think that's great about that is what the return order we actually want is option and then the state. So I can change that in here, but the method can stay there on the right. So we actually have sum n to this. And this is convention, basically kind of with unfold or the state monad, you have the bit that you're outputting here, and the next state here is on the right. Hey, Blue, good morning. Yes, I did solve part 2 yesterday, and I did it by reverse engineering. Very nearly just did it by hand. I can show you, I'm about to refactor it, but basically I back solved one at a time. And this here is basically the gist of the reverse engineering. I bit shift 3, and then I just run it through the program until I get the output that I want at each step. So that's 8 possible outputs at each set of 3 bits, and then we shift over 16 times. So that doesn't go too deep. Ah, yes, get your coffee. I'm just doing a refactor of all that code so far. Okay, and since we've just swapped the order made by this no output helper and output helper, we can delete this swap. In fact, delete that variable and just outdent that whole thing. And in this case here, if a equals 0, then this dot, no, this here, copy Nope, nope, that's not what we want to change. The output here. So we have an arrow to sum. Instead, we can just say dot output combo mod 8. All right, looking better, looking better. I'm gonna take this bit here. It's similar in all three of these. I'm just gonna make that private, private def. What do we call it? Div. Yeah, I mean it's really a bit shift. There, now we can put that on one line. Take out some of uh, the line breaks, make that easier to read. So b equals a over div. Oh wait, let's just put a in the div. So a over div. Uh, yes. Yep. So c equals div. You don't need to say a over div, just div equals div. B equals div. Hey, Hellhound, how are you? Morning and welcome. Morning. It's midnight. Just doing a little bit of refactor. Most recently, just making things more concise, added helpers to show that a state has output or no output. So you can see all the steps that are happening. Here, let's see, I don't want to do this variable, and we can avoid that state.no output. So if a equals 0, then we advance with no output. Otherwise, we copy, change the instruction pointer, and also have no output. Yeah, there we go. I'm just gonna take out these warnings. So notation.no warn. And what's the warning I'm getting from them? Hold up. We'll just search for string context. So annotation.no warn message equals string context. There we go. I should have done that a long time ago. What else? So these kind of outputs here, these can just be helpers inside the class. I'm gonna make this a method called run, so we can run the CPU to its final state with all its outputs. Def run, and sure, we'll return a list of int. And yeah, this works. Didn't we define run? No, it's called output. Okay, and similarly, we want this, but I'll call it end state. Yeah, I like to name it end state better. This doesn't need a state parameter. Okay. You feeling ready for tonight? I'm really tired. Like I'm making simple mistakes in everyday life. Not just here at the text editor. My part 2 is a general solution actually, because all it does is do the bit shift 3, and then it runs the code. So it runs the code that I'm given. At least I think it's general. Like if someone wants to provide a test case or you do, then yeah, go for it. Okay, so we have an end state, we have a run. I'm gonna replace those real quick. So all of these cases, we have that run at the end instead. Okay. Actually, who am I kidding? I should just comment this out because that's going to be refactored as well. So yeah, this was all some kind of test code. Here's our actual solution code. Oh no, this was our exploration code when we were coming up with our answer. So let's delete that. Below here is a bunch of test code from earlier. Well, actually more of this. We don't need this. Yada yada. Yeesh, I committed all of this. And these are our tests from the problem itself. We'll pull those up. Okay, I want to implement these, but I want them to be readily, I don't know, I want them to come fast. Okay, back solve. I should now use dot run. Start say dot run dot make string. Okay, let's see, what else do we have? Unfold, we unfold into this state. And all of this stuff can be commented because I want to be such that it's very easy to just copy paste this. So, I want to make basically a default CPU. So we'll call it init. So a int equals 0, yada yada, so forth. 2-minute timer. Oh, okay. Yes, we are running low on time. I appreciate it. Not a meeting stream. Good luck today. Oh, what's that supposed to mean? I don't spoil people. I'm too slow to spoil. You know what? I kind of feel you, Michael. Geez, I should just end early after part 1. But we'll see how long it takes. Is Copilot on? Let's enable those. Okay, just under 2 minutes. Okay, we'll get this in a sec. Let's set my day 18. Not unmuting the stream. Wait, hold on. Not unmute. Oh, I thought you said not muting. You're now. Mainly concentrate on part 1. Pretty busy with long workshops today. That's fair. I have an important meeting in the morning as well. I want to give a presentation, so I don't stay up too late. All right. Good luck, everyone. Day 18. Okay. Input is a bunch of coordinates again. Inside a computer. 2017 day 2, huh? Pushdown automaton is, and their algorithm is pushing whole bytes down on top of us. Oh no. It's going to cause bytes to fall into memory space once every nanosecond. Create a list of which bytes will fall in the order they'll land in here. This sounds familiar. We've done this problem like basically 2 times before, I think. Okay, 2-dimensional grid coordinates that range from 0 to 70, both horizontally and vertically. Okay, let's start writing that. Import, we're going to need area, point, and let's leave it at that for now. So now our area is 0 to 70, both horizontally and locally and vertically. Okay. Example is 0 to 6. Good to know. Each byte position is given an XY coordinate. Okay. We're in the top left corner. You need to reach the exit at the bottom right corner. You need to simulate the following bytes to plan where it'll be safe to run. For now, simulate just the first few bytes. They can make the coordinate corrupted. Corrupted coordinates cannot be entered by your historians. We have example if you were to drop memory space after the first 12 bytes have fallen. Wait, is this secretly a maze? With the third dimension being time? Um, okay, up, down, left, or right. After just 12 bytes, shortest path from the top to is 22. Simulate the first kilobyte. Okay. Afterwards was minimum number of steps needed. Okay, this is just a Dijkstra. So, well, grids. It's going to be some set of bytes. The bytes are falling. So val bytes. It's going to be a list of point. Input dot collect. Yeah, it sounds easy for part 1, right? They just basically gave us a maze, but it probably has like a time dimension for part 2. Okay, so we've parsed our points. I'm not gonna bother simulating time right now. I'm just gonna get the grid at that point. Well, grid 1024. Okay, what do we do? Set a point. What do we say? Bytes dot take 1024 to set. Sure. Def search. And we'll have a grid of bytes. I shouldn't call it grid exactly. We'll say blocked. Yeah, we'll say blocked. And that's a set point. And what we want is the shortest path. Okay, so import collection dot readable dot priority queue and map. There's not even like any kind of cost function. Well, I guess there is. No, not really. Yeah, super easy. This is just vanilla Dijkstra, vanilla maze solving. Um, uh, I don't know, order by distance to end. So let's put start and end outside of this val and equals at the bottom right corner. Area dot bot right. Sure. Okay, start 0, ordering by cost dot reverse. We can just make this empty as start. Priority key dot empty of point val or var this thing start. Maze solving is essential for admin code. I definitely recommend playing around with that a bit. So while visiting is not and then val next equals visiting dot adjacent not filter area contains, or we could say inbounds of the area. Filter not blocked. Or we can even say diff blocked. Yeah, and filter not cost contains. And next, not for each, and we're going to add to the priority queue. So cost of visiting plus 1, and then queue it. And then visiting equals pq.dq. Okay. So once we have all of that, we're going to take visiting or cost of visiting. Now adds 1 equals search. Hold on. Oh, missed a 2 there. Visiting. And we search blocked, which is grid 24. Okay, 302 for part 1. Easy peasy, 585, top 1000, smooth. Historians aren't as used to moving around. They're not going to be fast enough. You determine the first byte that will cut off the path to the exit. Okay, the first byte that will cut off the path to the exit. Hey, this seems approachable. Hmm. Well, now we want to quickly determine if there is a path. I think I just binary search over the length of the bytes. Thank you, thank you. Okay, so we'll do this def grid. Oh, and let's see if priority queue is empty. So let's make this an option of int. And how do we make sure this won't crash if we can't hit the end? We have a DQ option. We don't necessarily check if the queue is empty. Because if we still have a point that we're visiting, then that point might get us the next point to visit. This is more of a connected components. Yeah, this is more of a connected components problem, not a Dijkstra anymore. So I don't think I'll modify my part one. So def component, give my grid, or locked set a point. Let's just call this flood fill. And from point. Okay, so we can do iterator dot. Let's just return a set a point. Yeah, we just do a flood fill from the start at every step. So we only can do from here, just from the start. So iterator dot iterate. So we start with a set. And we'll call that visited. Let's see. Let's do a def next in a point and a grid. Or a set of blocked, rather. And we'll just do this code from part one. So it's going to be P. All right. And yeah, that gives us a setup point. So it's going to be next from visiting given blocked. So we have next visited. Or visit.flat map next, rather. Your maze looks different from the example. Oh, for part one? Yes. So visited.flat map. Pass along the blocked. Oh, wait, flat map next, rather. There we go. So we'll call this the next. And then we're going to filter not visited. Hold on. We need visited and visiting. So we'll do set.empty point. So we have visited and visiting. Okay. So visiting the flat map to get the next. And option not when. Let's see, what are we outputting? We're outputting the visiting, right? And when next is non-empty, we output it. Wait, if next is no, and visiting is non-empty. Okay, and if we're going to do it that way, you might as well define next here. Okay, so iterator, did I say iterate? I meant unfold. Okay, so this is, we'll call this the steps. And then we'll take steps.gswid. All right. Arrow bounce, you're done with today. It's had a few false starts and forgot to break out of loops. I hope I'm not making a mistake here. I've decided not to do Dijkstra for part 2. I'm just going to do a flood fill, but I'm going to binary search it. Visting. Why do I keep typing visting? And this cost is actually blocked. Oh, wait. No. That should remain in my Dijkstra code. Filter not cost that contains. Okay. Oh, right. We were about to modify the search, but we're not going to use the search. Yeah. I mean, I'm giving myself more work. Maybe I should just have let the Dijkstra early terminate. I mean, the Dijkstra will just turn into a flood fill anyway, right? If it can't reach the end. So it'll early terminate if it hits the end early. But otherwise, it's just flood fill with extra steps. Let's see. So found what? Set. Hold up. We do need to use visited. So flat map next dot diff visited. Okay, visiting becomes the new visited, and visiting next goes there. What's the issue here? Requires a tuple. I'm giving it tuple. Oh, hold on. Hold up. It's giving me completely the wrong error message for that syntax error. Because I think this is what's actually wrong. You have to destructure tuple. Why am I fighting with a syntax here? Yes, reusing the variable. I thought I would write, I would thought I'd bang this flood fill out faster than this. I seriously don't understand this error I'm getting. I'm supposed to return. Okay, let's give this. Oh, hold up. I see, I see. So visiting is output, and then the next state is visiting to. Okay. Okay. Great. Now, def binary search. Let's do the binary search in a range. Range of indices. And what are we searching for? Coordinates to the first byte will prevent exit from being reachable. Okay. And I don't know, I guess we'll give just the index. Or let's just give the straight, I'll just straight give it a point. Okay, and we can make this recursive. I don't like whatever Copilot is going to do here. Val left right equals range.split at range.size over 2. Okay, and we check. So def reachable given a set of blocks. Okay, and this will be I don't know. It's gonna be we're gonna do the flood fill from the start. So flood fill from the start. So we're doing it from the start. So flood flow blocked that contains end. Okay, if left.last So reachable left at last. Let's pass the index into here. So val blocked equals, I know, will be how many we take. So we're going to do bytes dot take n dot to set. Okay, and okay, if the left dot last is reachable, then we binary search in the right. Right. Otherwise, if it's not reachable, we binary search in the left. Else BS left. Easy peasy. We just need our base case. So if range.size, well, let's see. If it's size 2, if it's size 1, we'll have an empty range on the right. Hold on. 0 to 0 dot split at 1/2. Val A B was that. Okay. So A is empty range. So if range dot is empty, then false. Oh, it should never be empty, actually. Okay, so you don't want to be splitting one that's of size. Just gonna triple question mark that. We should never get there. Once if range dot size is 2, and we can split into 2. Well, if it's 1, it should just be that. So once if range dot size is 1, then we'll just add an assert just in case. Assert reachable range dot start. And we just return. No, we assert that it's not reachable. Right? It should be blocked. And we return that block. So bytes at that index at range dot start is what we return. Okay, like I don't think we should get to those two cases. But if we do, they're handled. So if range dot size is 2, then we just take a look at them each. So val L equals range dot head at min val R equals range dot max. If reachable R well, actually, if reachable L, then we return R. Otherwise, if it's not reachable, then it's just L. So we do bytes L, else bytes R. All right, and everything else goes in else. Okay, I had too many if else branches in those base cases for like a 2-line algorithm. But we're going to BS the bytes dot indices. And yeah, that should do it. 814. 8 comma 14. Okay, well, 814 is wrong. Um, let's see if this code here is actually necessary, because we should get to 1. Yeah, it should be possible. Well, hold on. If the last on the left is reachable, yeah, let me search on the right. Otherwise, we search on the left. That's fine. Um, if the range size is 1, then we just return that one. Straightforward. I'm going to change this to return to index so I can see what index I'm getting. Hold on. Oh, I might be off by 1 because bytes, we take n. Let's say we take 3. Index 3 is going to be the one past that. Okay. We shouldn't be taking n. We should be taking n plus 1, everything including that n. No. Okay, this range is a range of indices of a byte, right? We want everything until that byte. So if we have 0, 1, 1, 2. So let's say we're taking index 2. Then to test, at the far right, we're gonna have 3. We're gonna be taking 3. Yeah, we're taking everything before it. So take n plus 1. Okay, that was my bug, off by 1. Go back to returning a point. 1070. 1070 was also wrong. 1070, and what was my previous answer? 814. Okay, well, let's investigate with that index then. I guess we don't need this range size equals 2. This should still work actually without it, because the 0 and 1 are handled. Right, like the 0 shouldn't be hit. Wait, are we getting a different answer now? We didn't change anything. Well, we commented this out. Did I write this bit wrong? Okay, if reachable on the left, then it should be bytes R. You should return bytes R. Otherwise, L. 2432. Okay. Now we've got it. And we didn't even need to write that case. So we wrote an extra case and it was buggy. We didn't even need the case. More code you write, more. The least buggy code is no code. Okay, there we go. There we go. We got it. Oh my god, I can sleep early today. This is great. I threatened to do only one part, and AOC decides to let me sleep. Okay. I mean, today was straightforward, right? It was a straightforward Dijkstra. I don't think I even had any bugs in there. Straightforward flood fill. No bugs there, just a weird syntax error. And straightforward binary search. Okay, maybe just a tiny bit of cleanup. I did take too long for part 2. I think maybe I shouldn't have written the flood fill. I should have just kept going with the Dijkstra. I'm not sure if binary search was even necessary, but I did it. Um, Great. Well, I do still have a little bit of energy, so I just want to finish my thought with a refactor. How's everyone else doing? So we had day 2017, 2024. I'll check leaderboards real quick. Um, okay. I'm relatively early finished today, I suppose. So for day 18. Yeah, took fifth on part 1, 11th on part 2. Maxim, I don't know if he's here. Arrow bounce finished in 13, 5-minute delta. Oh, I actually did finish part 1 before. Hey, that feels good for me. I know you're fast. I'm surprised I didn't write bugs because I am so tired. Well, I did write a bug, but you know what I mean. Um, okay, I was writing up an init helper here. So, instruction pointer should default. Oh, these will all be longs rather. So, long. And the instruction pointer should default to 0. And then the program vector int should default to empty. Okay, CPU a equals a, etc. Is Copac completion off? I just wanted to autocomplete this. I should know what I'm doing. Okay, whatever. Okay, now here we can write something like init a equals a. What if we had like helpers that's, oh no, that should be fine. So init a equals a and and then program equals start program. That run. or cpu.init. Okay. I want to have maybe like a load helper so I could just load in a program that I want into something. Yeah, let's do that. Def load program, and it's going to be int just star variadic argument. This dot copy with program equals program dot to vector. Does that work? Okay, so here we can CPU init with a equals a, and then load a program, start state.program. Or we can do like start state.load or set a. Star. Okay. I wonder what this is here. Unused local definition. Oh, was it unused before? I think those answers are still correct. No, this was day 17. So ANS 1 is still correct. ANS 2 is still correct. Okay. These are my tests. So back solve. I'll remove that for now. We have the ultimate test. Um, okay, yeah, I'm happy with that. Now let's make our test cases, and then ways to test them. So let's not worry about this. So here is one. Let's do cpu.init c equals 9 load 2 comma 6. And what were the conditions for that? B should equal 1. Okay, so there's our test. I guess we don't run, but we not need the end state. End state.b equals 1. Cool. Look, so much easier to write that test now. I mean, it wasn't that much of a burden to do this. This stuff here. So we had cpu.init equals 10, and then we load that. And in this case, the output would be 0, 1, 2. That output equals list of 0, 1, 2. And we have an issue with this. Medellin, yeah, super easy today. I'm glad they gave us a break because I do need sleep. But super straightforward. I mean, I can show this was just a plain Dijkstra, right? This is straight up vanilla Dijkstra, nothing special, no special cost. I think you need to be with Dijkstra, honestly. DFS, BFS would have been fine. And for part 2, I used a flood fill, just the same normal flood fill and a binary search. So this was an elite code problem. Um, I mean, I guess you didn't have to use binary search, and you also didn't have to use flood fill. I should have just kept using the Dijkstra that I already wrote. Cannot be compared. Wait, output? No, we run. There we go. Okay. So running more use test. So for register A, CPU.init, A equals 2024.load this program 015430. Let's see what output of that. What were my tests for that? .run equals list. I'm just going to copy paste. And then same thing. Dot. Great. B contains 29. So CPU.init B equals 29. Then load 17 end state dot B equals 26. Cool. I'm assuming this one came out as true. Okay, great. And 2024 C contains CPU.init B equals 2024. C equals 43690. Load 40. End state B is 4354. Alrighty. So I have all my tests. There's that. I think guys cleaned up a little. You did BFS and brute force part 2? Oh yeah, okay. Brute force. How long did that take? That's funny. Yeah, I suppose I should have just BFS'd. But I did a Dijkstra because I anticipated, I thought like part 3 might be, or like part 2 might be with another dimension or some fancy shit where there's now some new cost or something. But nope. Part 2 brute force is 1.9 seconds. Yeah. I shouldn't have written anything new. I should have just kept my Dijkstra. I thought it'd take me like a minute to bang out a flood fill. But oh well. Am I satisfied with this? I think I'm pretty satisfied with this. I could add like a debug that allows me to test like get all the states and all the output at any time. But overall, I think mostly I was happy to turn this into like a bunch of one-liners that are easier, just condense it so it's easier to see that's correct. Okay, so we had some cleanup. Day 18 needs no cleanup. What do you miss this? Okay. Oh yeah, you start at 1,000. They're only like 3,000 chords. Yeah, totally. So if the answer is like around 2,000 or something, that would have been half your time off. Yeah, I knew there were 3,000 coordinates, and I still decided to binary search it. I think partially, I do kind of like writing this binary search. I like writing it with a range instead of using indices. because I like doing this right here. So this line of code, left, right, ranges, range.split at range.size over two. It's just so I know it's compact, and you don't have to mess with i's and j's. Anytime I mess with i's and j's, I can't do it. I get off by ones. Um, right? Like here, I had an index. This was my one bug in this program, was I didn't do a +1 here, and it's because I'm using an index directly. Hmm. Alrighty, let's let's find someone to raid. Um, I kind of hope there's someone working on past days, doing some catch up or whatnot. It'd be nice to revisit. The last few were super fun. Like today's wasn't as fun, but it wasn't as demanding. We could just sleep. Oh, Tony is up. Let's say hi to Tony. Is the stream delay huge? Let me check my stream health. Yeah, my bitrate has dropped. So there's a little bit. Uh, needs more quick sort. Always need more quick sort. Does anyone have fiber? Because we finally have fiber in this area. Just got a piece in the mail inviting us to do it. And I'm so excited to do that, especially for the stream, especially where I'm dual streaming to YouTube. Um, it's barely enough bandwidth to upload. Okay, right. Oh, we're on TV. Tony is probably working on past problems. If I had the energy, I'd be doing past problems right now, but I just so need to sleep. I'm so glad tonight's was easy. Uh, seriously, it burned me out. All right. Well, thanks everyone for stopping by. I hope you all had fun on this too. Hmm. And good luck with the rest.